I'm television meteorologist Mike Fairborn. It's my business to be concerned about the weather and its effects. One important effect of the weather is the deterioration of asphalt or blacktop pavement. We all need to be concerned about the deterioration of asphalt pavements because we depend on them for safe transportation and because so many of our tax dollars go into maintaining Minnesota's asphalt pavements. Oxidation by sunlight, surface wear by traffic, and water infiltration are major causes of pavement deterioration. One of the most cost-effective maintenance methods for counteracting pavement deterioration is seal coating. So I want to go over with you what I've learned about seal coating from the experts, Minnesota's public engineers and pavement maintenance professionals. They've provided me with some solid research data, but they also stress that it takes skill to put down a good seal coat, skill that comes from experience. Later, I'll cover the basics of planning a seal coating operation and give you some tips on how to do the job right. But first, I want to explain the purpose of seal coating. A seal coat works to protect a pavement just like paint protects your house. Paint doesn't add any strength to a house, but it keeps the sun and water away from the structure so strength is maintained. Seal coating does the same thing for asphalt pavement. There are 4 main types of seal coats used in Minnesota. This one is called fog seal. In a fog seal, dilute liquid asphalt is sprayed over the pavement to create a thin protective layer. This is a slurry seal. It's a mixture of aggregate, what many people call gravel, and asphalt. It's pressed into a very thin layer with a special squeegee. Next, there's the sand seal. It's composed of 2 layers. First, liquid asphalt, and then a thin layer of sand is laid down and rolled into the asphalt. Last is the chip seal. Because chip sealing is the most common type of seal coating done in Minnesota, I'm going to concentrate on it here. Like a sand seal, a chip seal is composed of 2 layers. First, liquid asphalt, then a layer of aggregate. A chip seal protects the pavement like all seal coats, but it also offers an added benefit. The aggregate replaces the road's original skid-resistant surface that becomes worn down after several years of use. Now, you only get these benefits of a chip seal if you do it right, and you can't do it right unless you plan the operation carefully. The first step in planning is to decide which pavements need seal coating. That decision is based on pavement condition ratings gathered in the field. Seal coating is called for on pavements like this that have already begun to wear, crack, and dry out. But a pavement that has deteriorated this far will not benefit from seal coating. It needs more intensive maintenance, such as an overlay or reconstruction. Once it's been decided to seal coat a certain section of pavement, the next step is to select the right materials. As we've seen, the 2 components of a chip seal are liquid asphalt and aggregate. In choosing the right types and amounts of both materials, it's important to apply an engineering design process. Because there's a limited choice of aggregate types available in each particular place, you usually have to choose your aggregate first and design around it. When choosing an aggregate, size is one important consideration. These are the standardized sizes of seal coating aggregates, and this is the most commonly used. The FA stands for fine aggregate, and the 3 designates the size range. Most pieces of FA3 are about 1/4 inch across. The shape of the aggregate is also important. We've had this sample made up during a typical seal coating operation to show why angular shaped aggregate is best. It's chip seal laid on a piece of plywood. If you look closely, you can see how the angularity of the pieces allows them to interlock so they can't easily be dislodged. Also, it's the angles that make for a skid-resistant surface. But cost is also important. To get the more angular pieces of aggregate, the rock has to be crushed, and that's more expensive. Sometimes you choose a less expensive and not so angular aggregate like this. No matter what kind of aggregate is used, it has to be clean. Like these samples, dust and dirt will prevent a good bond between aggregate and asphalt. Also, the aggregate has to be hard so it'll stand up to snowplows and traffic. Many minerals are hard enough to do the job: granite, quartz, dolomite, and some limestones. Again, the choice is usually made according to what's nearby. Each mineral has a naturally occurring electrical charge, either positive or negative, and you take advantage of that fact in choosing asphalt to work with your aggregate. Asphalt can be manufactured to have either a positive or negative charge too. As we know, opposite charges attract, and that's just what we want, aggregate that bonds to the asphalt. So once you know which charge your aggregate has, you order asphalt with the opposite charge. Of course, in its finished condition, asphalt is pretty hard. To allow it to be put down in a thin, uniform layer, the asphalt is made into an emulsion. That means it's mixed with water and a wetting agent and then heated. After it's sprayed on, the emulsion breaks, as they say. That means the water evaporates and the asphalt adheres to the pavement and sets. Asphalt emulsions are specified according to whether they're positive or negative and according to how quickly the asphalt sets. For example, one of the most common types of asphalt emulsions is called CRS. The C stands for cationic, which is the technical term for positive. By the way, the term for negative is anionic. The RS stands for rapid setting. The rapid set helps you get traffic back on the road sooner after seal coating. There are also slow and medium setting types for situations where you want the liquid asphalt to sink more deeply into the surface. Besides choosing the types of aggregate and asphalt for seal coating, you have to decide how much of each to use. Determining how much aggregate to put down is pretty straightforward. Your goal should be a layer 1 stone deep, like this. But figuring out how much emulsion to use is a little more complicated. The goal should be to put down enough emulsion so that 50 to 70% of each stone is embedded in asphalt after rolling. To achieve that, you have to take several factors into account: the shape and size of your aggregate, the amount of traffic that uses the road, the condition of the pavement surface before you seal coat, and the amount of asphalt in the emulsion you're using. There's a reliable formula that can be used to give the proper weighting to each of these factors. It's fairly complicated and I won't get into the details now, but the MnDOT Materials Laboratory can help you apply the formula and determine the right proportions for any specific project. One thing the people at the lab will emphasize is that in order to control the amounts of aggregate and asphalt you're putting down, you have to calibrate your equipment regularly. And I'll get back to that in a few minutes. For now, let's say you've chosen your aggregate and your emulsion, and you've decided how much of each to use, so you're all ready to seal coat, right? No, you have to choose your weather. Well, maintenance supervisors probably wish they could call up and order the weather just like aggregate and asphalt, but they have to check the weather report, mine I hope, and decide accordingly. Usually they make the final call whether to seal coat the night before the project is scheduled. What you want is classic Minnesota summer weather, at least 70 degrees, hotter is better, with humidity between 40 and 80% and low wind. All of these conditions are best for setting the emulsion. You also want a dry pavement while you're seal coating with no rain until well after the emulsion breaks. The wrong weather can lead to a failed seal coat, so it's better to postpone seal coating than to do it when the forecast isn't right. Besides thinking about materials and weather, there are also several tasks to take care of way before you seal coat. Usually a year ahead, you do a good job of patching, crack sealing, and leveling the pavement so you have a uniform surface. Also, a year ahead of time, it's important to contact the utility companies and be sure they do any necessary work. You don't want them cutting into the pavement right after you've put down a new seal coat. A few days before seal coating residential areas, notify residents and businesses on the affected streets and post no parking signs. That makes things easier for everyone. Besides all of those considerations, an important part of planning is to check your equipment. Ideally, you should have all of the following ready to go: traffic control and loose gravel signs, sweepers. The open kind may be okay on rural roads, but in residential areas, you need pickup sweepers. A distributor designed to put down the right amount of liquid asphalt, no matter what speed the truck is going. You also need an aggregate spreader, trucks to haul aggregate, and rollers. A recent study showed that the most important element in a seal coating operation is having the right equipment in good working order. Not surprisingly, the spreader and the distributor are most important. As I said before, you need to calibrate your spreader and distributor often so you know how much material they're putting down. To calibrate your spreader, you recover a square yard of aggregate and weigh it. That shows what you're getting for a given setting. The process of calibrating a distributor is similar. You use a 1 square yard pan to recover asphalt and compare the actual volume with the reading on the gauge. Besides good equipment, you also need a good crew. In the study I was referring to, it was found that another key to successful seal coating is having people with plenty of experience and skill in using the equipment, which brings us to the seal coating process itself. Now that we've covered the things you need to think about before you seal coat, let's look at how to do the job right. The first thing to do on the day you're going to seal coat is set up your traffic control. The best thing is to detour the traffic during the operation. If that's not possible, use flaggers and signs. When traffic is clear, sweep so that you have a clean surface for the asphalt to adhere to. Then cover manholes and other utility openings. You can use cardboard, tar paper, or sand. Now you're ready to shoot emulsion and spread the aggregate. Here you see how the various pieces of equipment are lined up on the job. And here you're looking at picture-perfect shooting. Notice that the overlap between sprayers is the same all the way across. That's what you need to put down an even layer of liquid asphalt. The overlap of the sprays is affected by three things. One is bar height. You get the same result with the bar too high or too low. More liquid asphalt in some places than others. That's called streaking. The second factor is pressure. You need the right pressure to get correctly shaped sprayer fans like these. The third factor is the emulsion temperature. The correct temperature will vary with different types of emulsions. If any of these things goes wrong with the shoot, you can end up with streaking, and that may lead to flushing like this. The emulsion has oozed up on top of the aggregate. Skilled distributor operators know how to avoid this. In addition to the distributor operator, two other skilled positions on your team are the spreader operators. It takes plenty of experience to put down that one stone deep layer just where you want it. But even with expert spreader operators, you still need people assigned to hand spreading and picking up aggregate in spots that receive too much or too little. Now, here are a few important ideas for aggregate truck drivers. Never cross exposed asphalt. Avoid turning on newly laid aggregate, and stagger your paths over the aggregate to aid in rolling, which brings us to rolling itself. You roll for two reasons: to embed the aggregate and to orient the stones. You want a flat side of each stone down and all of the stones in a tight interlocked pattern. Pneumatic tire rollers do the best job because the multiple rubber tires are good at getting into irregularities in the surface. When deciding how many rollers to use and how fast to run them, keep in mind that you have to embed the aggregate before the asphalt breaks. 2 rollers are a minimum for most jobs. 3 or more are better. You want as many passes as you have time for. Over-rolling is pretty much impossible, and slow rolling is better because it kicks up less aggregate. That applies to aggregate trucks and traffic as well as to the rollers themselves. If you put traffic back on a new seal coat right after rolling, the flagger should keep the maximum speed down to 25 miles an hour. The last step is sweeping excess aggregate. In most cases, you should do this the day after you seal coat. Sweeping that soon after seal coating may be a change from what you're used to. There are 2 reasons to sweep sooner. One is safety. Loose aggregate means less control of vehicles. The other reason is that embedded aggregate can be dislodged by traffic pushing around the loose aggregate. Furthermore, there's no advantage to leaving the aggregate on the site. No more aggregate can be embedded after the asphalt sets. And in normal weather, that happens within a few hours of application. Well, that's a pretty quick overview of seal coating. I know I've covered a lot of territory here, so I think it'll help if I review the main points. First, remember that seal coating is a protective measure. Its purpose is not to add strength to the pavement, but to protect the pavement. In planning a seal coat, you need a combination of liquid asphalt and aggregate that's designed to account for your particular conditions. You also need the right weather, a nice hot summer day. Your equipment has to be in good working order and correctly calibrated. The sequence of steps is sweep, shoot, spread, roll, and sweep. Sounds like a football play, doesn't it? And that's not a bad way to think of seal coating because it takes a lot of skill and teamwork to be successful. I'll do my part by predicting some nice hot seal coating weather for you this summer.